In this video clip, we are going to learn how to calibrate SWAT model in R environment. R is also an open source statistical programming tool. So now let's have a look. How can we do that? It's actually three-step process. Step 1, we have to copy the text in and out file, all the files from text in and out folder. And the second one is to put observed data and the executable. And the third part, we will run the script. Let's do it together. This is our model. So inside the model there is a scenario, and these are the two simulation folder. So we copy all the input files, and then we put in a calibration folder, calibration with R, and I made an empty folder with text in and out. Now we paste it here. So now we have to copy the observed data and the executable and paste it inside of text in out. Now we run open R, and then we set up our directory on the model on the text in out folder, and those are calibration with R, text in out. Okay, and then now we put a new script. I have written some code, so there I copy the code. I'll explain it later. Now we paste it in the new script window, and then we select and run it. We can see now it's SWAT is running inside calibration inside R. So you can see that I'm using an executable which I modified optimizing the code in Fortran. But you can get the executable when you install SWAT in C drive in ArcSWAT, and these are the executable that it comes when you install the software, when you install the model. So I have seen that in the R environment it is 5-6 times faster than the interface itself. So once it is done, it will automatically prepare the time series file reading the observed and simulated relationship. It may take a little time, and so now we can see that the graphs that we got in Excel is the same, close to 500, and the statistics NASH uplift efficiency is also 1.75, 1.76, so it's the same, and the graph patterns are also same. Since it is not calibrated, that's why it is looking like that. So after calibration it would be okay. We'll do it in another session. Now for the flexibility is that we can change the parameter. This in the basin file there are some basin parameter, so we can now, let's say we make a change at the evaporation component ESCO, and we save it, and then we can rerun the R code, select again, and then we run it again. So it's quite flexible. We don't have to open the MDB file and put it in Excel. So it will automatically do once it is finished. So you can now see there's not much improvement, but we can see the statistics. We can find the difference. This is 1.70. So if it's close to 1, it's better. It's 1.70 is better than minus 1.76. Minus 1.70 is little better than minus 1.76. So that's how we can run SWAT in. So let's see what are the code inside. So first step is to run this system file, and then the second step is to read the observed data. By the way, we can see the structure of the observation data. It's also very simple. So these are the 3 columns, and first 2 columns we don't need. So now we can, in the third portion we are just calculating the same statistics, because all these relationships are based on observed and simulated relationship. Actually the idea I got from someone called John Joseph, and then I try to code it. In my next tutorial I'm going to put SWAT calibration in MATLAB interface, and we'll prepare some spatial map, and then we'll go for automatic calibration using genetic algorithm, and then we'll make some spatial maps. So in case if you need some feedback or if you have any comment, please do not hesitate to send me your feedback. Thanks for watching.